Hi, I've been a tech volunteer for the last 8 years in our local community here, and I've taught electronics and coding and other things, tech-related things to students in the library system as well as in the school system here. And I recently agreed to teach a 5-day code camp this summer, and I was going over the curriculum that I was thinking about teaching and maybe explaining my choices of why I did it this way, and um, thought maybe it'd be good to share on the video, and uh, maybe others can uh, get something out of it. So I've taught both text-based coding, like using Arduino and uh, to teens, and also block-based coding. I found that students tend to enjoy the block-based learning better, and I think they stick with it longer, so therefore they learn more about it. So I'm going to stick with the block-based coding this time, and I like using code.org. I'm signed up as an instructor so I can follow my students' progress, but anybody can sign up as a student and or sign others up as a student and um, uh, get them started on the same lessons that I'll be using. So I'll put links to it, but I think this express course is about the right length and covers enough material to get students going. So and a couple reasons I like the block-based coding better is one thing, you're able to do it all browser-based. You don't have to uh, download IDEs or libraries or anything like that. And uh, when you're dealing with a local library, that's always a plus because if the library computers don't have a program on it, it's a hassle to try to get the IT department to load up another program on there. So that's one reason. And another reason is that with the blocks, the beginning students don't have to worry about syntax, extra semicolon or indentation or whatever that they need to worry about. So um, that's I think it for beginners, it lets them concentrate on just learning the code part of it. So this course, it goes through, well, let's start out with, so they break it up into different lessons, and they start out with just statements, and then they get into other stuff. But they usually start out with a video, usually explaining the concepts and just a short video, and it's usually a diversified person or famous person talking about just introducing it to show that it's not just for uh, one set of people, and everything. But they do a good job of explaining it, and then they go through a series of lessons, and uh, they start out with just statements. So we can show like one of the lessons. And these are all, like I say, they're based on a graphical thing here. And the blocks, you just click on them and move them in and out. Start with them over there. You can throw them away and bring them back. So they tell you up here with what your goal is, and follow the path to get me to the pig and avoid the TNT. There's no TNT in this one, but oh yeah, there it is right there. If you run into that, you explode. But so this is the code that you need to get to the pig. This is Angry Bird, so the bird's going to get to the pig. So it's got some sound to it and everything, and you get some positive feedback when you get it done right. But say if you didn't get it done right, you get a little bit of a different sound so that you know that you got to keep going. So in the past, students have always liked this, and you get this little encouraging thing. Not quite right, but see what's not quite right. So anyhow, So, and then each one builds on the next one. So this lesson, you got two choices to make to get to it, and you got to decide the rights and the lefts and everything. And they start out giving you a lot of hints, like already coded here, and they also get into like debugging, where they'll give you the wrong moves, and you got to tell them which one's wrong on it and everything. So they get into quite a few things on that. So we'll go through sort of what the thing is. They got statements, and they got debugging, like I said, and they give you some code, and you got to figure out what's wrong with it. So that's a great skill to learn early on in your coding. You can say they do, art with a different thing and everything. But then they get into these sprites. So sprites, if people don't know, that's the objects on the screen. It's a game-based thing or a scratch-based thing. The objects on the screen, whether it's a spaceship, a cartoon character, or just an asteroid rock or something, they're called sprites. And once they're created, then you can choose how different things interact with them. So if a ball sprite hits a paddle sprite, what happens? Does it bounce off, or if a asteroid hits a spaceship, does it explode or whatever? So you got different choices there. So young people are definitely interested in becoming the next great game designer. So this is a good way to give them a little taste of it. So they have several lessons about making and interacting with sprites. Then they get into loops. This is a Star Wars based theme thing. So they get into loops and the nested loops. And they get into conditionals with the if-else statement, while loops, more conditionals, do until loops. So while a condition is met, more conditionals. Then they get into functions even, so, you can make your own little blocks of code, groups of code that you can repeat. So we talk about that. Functions, more functions. Then they get into variables. So with this type of block-based coding, you don't necessarily need to get into variables early on. So as you can see, variables are quite a ways down to the list. So they do that, bring in the variables toward the end. And then for loops, of course, you're counting your variables there as you're doing those. So that's what the course is. It's designed to be a 20 or 30-hour course, but I've taught it in the past, and most people get through it. If they're interested, they're going to get through it in probably 15 hours, or if they're not motivated, like I say, these are all after-school programs, and they'll drop out. They choose to come, and they can choose not to come as well. And if they're not interested, I find that they're either really interested and go through it get through it in a good time, or they just don't show up. And either way works. They either know, they find out that coding might not be for them. So it's a useful lesson for them. Either way, it works out. So like I said, I figure 15 hours they can probably get through this. So that's like 3.5 days. We're doing half-day sessions on our code camp. So they're going to have about probably a day and a half, 2 days to do something else. So I decided to use like I said, the same reason, block-based coding for hardware. And again, it's because it's browser-based, and just plug in a USB cord and they just work, and it's kind of fun that they can do that. So like I said, the instructions are real simple. And it works with, I think they started this out for the microbit, but they've added Circuit Playground, and now they've added the Raspberry Pi Pico as well. We have some Circuit Playgrounds. If you don't know what that is, that's like a little development board from Adafruit that has all kind of buttons and sensors on it, and has a piezo buzzer so you can make some music, and the NeoPixels and everything. And we have a half a dozen of them, so we'll be using them in the class as well. But like I said, for the using them at the library, having it browser based is key. So we'll get into that, and then I'll probably have some Picos on breadboards, and we can learn a little bit about wiring up basic LED circuits and maybe a switch circuit or something along the way. But we'll only have a day and a half, so we'll get to what we can get to. So this is the browser-based IDE or development area for the thing. So it's like I said, the instructions were on the other page, but I got a little Pico W here on a just bare. It doesn't even have any pins soldered onto it yet. I got this mailed to me a while back when the Pico W came out. So how it works is you have just you got your different groups of blocks that you can use, just like blocks over in code.org, and but like you can set your lead to on and off, so red's off. And this is like your shell where you can just play with them by just clicking on them. So I got my Pico W. This is the onboard LED. Oh, I got to connect my board. That's what I haven't done. So anyhow, so it tells you, gives you instruction. So we'll start. This board already had it on it, but we'll start over. So if we do this, it says update to firmware, and it gives you instructions. So we pick out that we want our Pico W, and tells you how to do this. Of course, you don't want to, if you got MicroPython and some files on there, but don't do that because it's going to overwrite them. Make sure you either back up your MicroPython files or have a fresh board when you do this. But you just hold down your boot select button and plug in your Pico. Let's see if I can do this. Probably not. So I'm holding the boot select and pushing it in, and that was the instruction. So you say okay, and when you do that, you're going to get this window picked up, and all you had to do was hit the save button. It already picked it. You're saving, and it's saving this UF2 file. It's a different UF2 than MicroPython. It's the one for Microblocks. And you just have to hit save. It told you on the previous, hit save, and once that's done, now you just connect to the board using your thing here. It says connect, and you pick your COM port on a Windows machine. I'm not sure what it would be on your, probably something similar on an Apple or Chromebook. And you see it's green, so we're all good to go. So now I should be able to show off like how this shell works. So you can see the onboard LED came on, and now it's off. You turn it back on. So this is like your shell where you can just interact immediately by just clicking on a thing. But you can also program your program in here. So we go down here to the control, and we start off with a when started, and we'll just do a repeat so many times, and we'll do a blink. So we'll turn the LED on, and you see how the things, you can either click it here, but if you click inside the box, it doesn't look like it'll fit, but it just expands to do it. And we got our sleep thing. It's called wait here. Turn it on, wait, turn it off, and then we need another wait for our blink. And just keep sneaking in there. So everything inside this little C thing here is what's going to be repeated whatever number of times it is. So when I click this now, it'll run. So blinking on and off 10 times. and then it's finished. So it looks like it were controlling this from, you know, the screen, but this when you put a when started, when you were just interacting with the blocks here, it wasn't code, it wasn't a program, so to speak. But when you put this when started thing and get this going, that actually downloads the code as you're doing it. It adjusts the code on the Pico. So the code is actually on the Pico. I don't have a power bank, but if you unplug it and plug it back in, you can do this with I'm on my computer still, but if you just use the regular power supply, give it power, it runs the program. So it's blinking 10 times again. So the program stays on there. So that's kind of cool. So anyhow, that's what I'm going to do. And for anybody that has a young person that they think might be interested in programming, but might not be ready to deal with all the syntax errors and the frustration assorted with that, this might be a good thing to do. You can check out the links in the video to check out what we're doing here. And anyhow, that's all I got for today. Thanks for watching. Have a great day, everybody.